Good afternoon to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of CSC, MLR Institute of Technology. In this video, we are going to discuss about the generating functions of recurrence relations. So, what is generating function? Then, how to find out the series of expansion or functions of sequence, and we can understanding the functions of sequence by taking some examples. So first of all, coming to the definition of generating function. What is generating function? Then let A0, A1, A2, A3 and so on up to infinity be the set of real numbers. Then that is set of all the real numbers. Instead of writing each and every term in the expansion, we can summarize as a An. What is n? N is in between 0 to infinity. Then the series of power of x such that generating function is written as g of x equal to a0 plus a1x plus a2x square plus a3x cube and so on infinity. So this is the generating function expansion. When we write it as a summarized form of generating function, g of x equal to sigma n equal to 0 to infinity a n x to the power of n. So suppose n value equal to 0, a0 x to the power of 0. X to the power of 0 means 0 only, that is 1 only, that is a0, first term. If you substitute n equal to 1, we can get the second term in the expansion. A and a1 x to the power of 1 means x only. Next, n equal to 2, a2 x2, n equal to 3, a3 x3. Like that we need to get all the terms. But we have to simplify all the terms in the expansion. We can write it as g of x is the summarized form of generating function. Here g of x is called as generating function for the series from an where n is in between 0 to infinity. Then g of x is called as a formal power series. Ai is the coefficient of x to the power of I. Then aixi is the term. So degree of I and a0 are called as a constant term. So what is generating function? Generating function is denoted as g of x equal to sigma n equal to 0 to infinity an x to the power of n is the summarized form of generating function. So what are the applications of generating function? It can be used to solve various counts of counting problems. So counting problems like enumeration, okay, that is a permutation, enumeration, that type of problems can be solved by using generating function. And the second application is it is used to solve recurrence relations. It is used to solve the recurrence relation. And to prove the combinatorial identities, we can use generating function. But in this unit, we are going to discuss about the generating functions for the recurrence relations. How the recurrence relations can use the generating function. Take the first example. Find the generating function of the sequence 3 to the power of n. So where n is equal to 0 to infinity. So we need to substitute the n value in the power of expansion 3 to the power of n. So what is the generating functions formula? G of x equal to a0 plus a1x plus a2x square plus a3x cube and so on infinity. Suppose n equal to 0, we are going to get, so in the place of n you have to substitute 3 to the power of 0, that is 1. Next, n is equal to 1. That is a0. a0 is nothing but the first term, that is 1. a1. a1 means substitute the second value. N equal to 1 means 3 power 1 into x, that is 3x. N equal to 2. 3 square x square. a2 value is 3 square x square. Then n equal to 3. 3 cube x cube and so on 3 to the power of n x to the power of n. This is the generating function expansion. Next, find the generating function of the sequence 1, 1, 1, 1 and so on up to some infinity. So that is what is the formula? First term is 1, second term is 1, third term is 1, all the terms are 1. What is the formula for generating function? G of x equal to a0 plus a1x plus a2x square plus a3x cube and so on infinity. Then what is the first term? a0, that is 1. A1. A1 is 1. 1 into x plus A2 is 1 into x, that is x square. Again A3. 1 into x cube. Again A4. 1 into x4. Again A5. 1 into x5. So like that we need to find out all. Suppose in the generating function sequence, if it is a 7 terms or it is 8 terms, it is easy to expand. Suppose there is a 100 terms are present. So we need to summarize the generating function. We need to summarize the generating function, that is called as a closed form of the generating function. Closed form of the generating function. How to find the closed form for the generating function? Consider the example. Find the generating function for an equal to 3 power n, where n is greater than or equal to 0. That means n values start from 0. N values start from 0 and so on. We need to find out with the help of generating function in closed form. So what is the formula for generating function? You can take either g of x or it is a of x. So we already find out n value equal to 0, 3 power 0 means 1. N value is 1, 3x. N value 2, 3 square x square. N value 3, 3 cube x cube and so on. Next. So my 1 should be coming to the left side. A of x minus 1, 3x plus 3x whole square, 3x cube and so on. X minus 1, take 3x as common, 1 plus 3x square and so on. So then take this one as a division, x minus 1 by 3x, remaining terms are 1 plus 3x square and so on. So this 1 plus 3x is equal to what? A of x, that is A of x. From this A of x minus 1 is 3x into A of x. We need to do the cross multiplication. A of x minus 1 equal to 3x into x. Then take A of x as common from this term, 1 minus 3x. 1 minus 3x, that is equal to 1. What is A of x? 1 by 1 minus 3x. So 1 by 1 minus 3x is also written as 1 by 1 minus 3x is written as 1 minus 3x whole to the power of minus 1. So instead of writing each and every term, we need to find out the closed form for the generating function. This is called as a closed form, that is the generating function. 1 minus 3x whole to the power of minus 1 is the closed form of the generating function. Now consider the second example. Find the generating function of the sequence 1, 2, 3, 4 and so on. Find the closed form of the sequence. So what is A0? A0 is 1, A1 is 2, A2 is 3, A3 is 4. So what is the formula for generating function? U of x equal to A0 plus A1x. A0 means 1 plus A1 is 2 into x, A2 is 3, 3x square, A3 is 4 into x cube and so on. This is considered as equation number 1. This is considered as equation number 1. Next. So from this, we know that 1 plus x square plus x cube and so on x to the power of 5 is generating function closed form is 1 by 1 minus x. Then we need to take the differential equations on both sides. Take the differential equation on both sides. Then we'll get d by dx of 1 plus x square plus x cube and so on x to the power of 4. D by dx of 1 by 1 minus x. D by dx of 1 is 0. D by dx is 1. D by dx of 2x square is 2x. X cube is 3x square plus d by dx of x to the power of 4 is 4x cube. 1 by, so we need to differentiate the 1 by 1 by x, we will get 1 by 1 minus x square. So this is the value. Okay. So already what is the terms? 1 plus 2 plus 3 plus, what are the coefficients? 1, 2, 3, 4. That is 1 by 1 minus x. It is written as 1 minus x whole to the power of minus 2. This is the closed form for the generating function 1, 2, 3, 4. That is, for that we have to do the differential equation. So differential equation on both sides will get the constant terms are 1, 2, 3, 4 and the corresponding values 1 by 1 minus x whole square is written as 1 minus x whole to the power of minus 2. This is the closed form of the generating function 1, 2, 3, 4. Next, consider the third example. So, an is equal to 9 into 5 to the power of n, n greater than or equal to 0. And the next one is n equal to 4, n greater than or equal to 0. What is the sequence? An. N 9 into 5 to the power of n. So what is the sequence of generating function? G of x equal to a0 plus a1x plus a2x square plus a3x cube plus a to the power of 4 x to the power of 4. So 9 into 5 to the power of 0, that is 1. N value equal to 0 will get 9 into 5 to the power of 0. N equal to 1, n into 5 to the power of 1. N equal to 2, 9 into 5 square into x square. N equal to 3, 9 into 5 to the power of 3 into x to the power, and so on. Next. So from all these terms, the common term is 9. Take 9 as a common term. 1 plus 5x square plus 5x cube and so on. 9 into what is the generating function for 1 plus 3x? 1 by 1 minus 5x. That is 1 by 9 into 1 by 1 minus 5x. That is 9 by 1 minus 5x. It is also written as 9 into 1 minus 5x whole to the power of minus 1. Next, generating function for 4 into n. 4 into 4 for n greater than or equal to 0. Next, what is the value? A0. A0 is 4. Next, A1. X. A1 is also 4. For all the terms, there is a common value, that is 4. 4 into x. Next, x square, 4x square. X cube, 4x cube. What is the common value in all these terms? 4 is the common. Take 4 as common. 1 plus x square plus x cube. What is the generating function? 1 by 1 minus x whole to the power of minus 1. That is 4 by 1 minus x is the closed form of the generating function. Next, find the generating function for the sequence a or equal to 0 to infinity, where a or equal to 1 if 0 less than or equal to or less than or equal to 2, then 3 if 3 less than or equal to or less than or equal to 5, 0 if or greater than or equal to 0. Next, we need to write the generating function for the sequence a equal to a or. R value is in between 0 to 2. We can written as 1. That means a or is a0 plus a1 plus a2 plus how many terms? Up to t terms. A3 plus a4 plus a5 plus a6, a7, a8 and so on. A0. That means R value is 0, then the corresponding value is 1. Then that means what is the generating function? A0 is 1. Then R value is 1. A1. R value is 1. Then that is also 1. A2 is also 1. 0 to A0, A1, A2. Then R3. So that means R value is 3. R value is 3. We can written as R value is in between 3 to 5. A3, A4, A5. Then R value is 3. Then for A6 to up to infinity terms, the value is 0. These are the values. What is the generating function? G of x equal to a0 plus a1x plus a2x square plus a3x cube plus a to the power of 4 x to the power of 4 plus a to the power of 5 into x to the power of 5 plus a to the power of 6 x to the power of 6 plus a to the power of 7 x to the power of 7. What is a0? That is 1 plus a1 is also 1. 1 into x is x. A2 is x square plus a3. A3 is 3x cube plus a4. Also 3x to the power of 4 plus a5. That is also 3x to the power of 5. Then after that for all a5 too, that is a5. up to a5. R value is equal to 5 is also considered as a 3. 1 plus x square plus for all the remaining values we are going to get the 0. That is the power of generating function. This is the expansion of generating function for the sequence a equal to a or r is equal to 0 to infinity. This is the expansion of generating function. Next, to find the generating function for the sequence 1, 1, 1 in the closed form. So, what is A0? A0 is 1. A1 is also 1. A2 is also 1. A3 is 1. A4 is 1. And so on. Next, what is the generating function? G of x equal to A0 means 1 plus A1x, that is x, A2x square, that means x square, x cube, x to the power of 4 plus x to the power of 5 and so on. So, we already done. That means take g of x, take 1 as to the left side, g of x minus 1 is equal to, take x as common, 1 plus x square plus x cube and so on, x to the power infinity. Then g of x minus 1 by x equal to 1 plus x square plus x cube and so on infinity. That is g of x minus 1 by x. This is equal to the, so that is equal to 1 plus x1, that is given generating function g of x. Then g of x minus 1 equal to x into g of x. That is g of x, as take it as common, 1 minus g of x, 1 minus x equal to 1. G of x is equal to 1 by 1 minus x. That is g of x is equal to 1 minus x whole to the power of minus 1. That is the closed form of the generating function. That is equal to 1 minus x whole to the power of minus 1. This is equivalent to g of x is equivalent to 1 minus x whole to the power of minus 1 is the closed form of the generating function 1, 1, 1 and so on up to infinity. Find the generating function for the sequence 1, 1, 1. So, just to return as it is, in the place of g of x, we can write it as plus 1 by 1 plus x. Okay. So, just you have to do the, so alternative terms, same terms, but it is a opposite. We have to take it as g of x equal to 1 by 1 plus x. That is also written as 1 plus x whole to the power of minus 1. Next, find the generating function for a or. The number of ways the sum or can be obtained. How many ways we have to choose? So, next, two distinguishable dice are tossed, E1 plus A2 equal to or, where E1 is in between 1 to 6, E2 is also in between 1 to 6. Total how many dice? 2 dice. Each die consisting of 6 values. That is A1x, A2x, A3x, A4x, A5x. So, that is A1x, g of x, area of x equal to A1x plus A2x, A3x, A4x, A5x, A6x. Second dice also 10 times. That is 6 times. A1x plus A2x plus A3x plus A3x, A4x, Q x to the power 4, then A5x, A6. Then what is E1? The first die value is in between 1 to 6. That first die value is in between 1 to 6. What is the generating function? G of x equal to First generating function. A0 plus A1x plus A2x square A2x square plus A3x cube plus A4x to the power of 4 plus A5x to the power of 5 plus A6x to the power of 6. So, first die value is in between 0 to 6. E1 is first die. E1 first die means 1 to 6. That is, say we have to consider the first term to sixth term. All values are 1 to 6 only. That is the first term. About the second term, second die is also in between 1 to 6. That is A0 plus A1x, that is the first die. All these are the terms. A1x plus A2x plus A3x plus A4x plus A5x plus A6, because the E1 value, the first die value is in between 1 to 6. Then after that second die also same thing. Then total generating function g of x equal to A1 plus A2 plus, that means first term is A0, that is considered as A1. Second term is A2x plus A3 x cube plus 8x square. First term is A1, second term is A2, third term is A3x square, A2x square, A1x plus A2x square plus A3x cube plus A4x to the power of 4 plus A5x to the power of 5 plus A6x to the power of 6. This is the first die. Two dice means we need to multiply. Two terms means whole square. That is the multiplication. Next, generating function. First die means 1 to 6. That means we need to consider A1x plus A2x square, A3x cube. E1 is all values. X to the power of 1, x to the power of 3, x to the power of 4, x to the power of 5, x to the power of 6. First die. Second die is in between 1 to 6 and the second one shows an odd number. That means odd powers. X to the power of 1. This term we need to consider 3 and 5. This is the g of x, first generating function, g1 of x. What is g2 of x? It is also contains 1 to 6 but only odd numbers. A1 x to the power of 1 plus A3 x to the power of 3 plus A5 x to the power of 5. Take g of x is g1 of x into g2 of x. That means A1x square, A1x plus A2x square plus A3x cube plus A4x to the power of 4, A5x to the power of 5 plus A6x to the power of 6 into A1 x plus A3 x cube plus A5 x to the power of 5. So, this is the total generating function. So, that is similar to first one, but the difference is it can show only odd numbers. So, we have to select only 1, 3, 5 only in the generating function. So, what we have discussed, what is meant by generating function, how to find the expansion in the generating function, then how to find the generating functions in closed form, and we can understand those concepts by taking some examples. Thank you.